For the exercise of a chest of drawers, we now have the option to draw this chest of drawers on a new plane or on an existing plane like here. I can set a reference point, can cut out this reference point, now create a new plane, enter the name chest of drawers here. The scale is, for example, 110, so I also enter the scale 110 here. The base height of the plane should always be 0. You can also influence the order of the planes here. Move the plane up and down here if you want to have a sorting. I want, but that is irrelevant. In the end, we now have a new sheet, a new plane, and can paste the reference point that we just copied, and that too at the original position, in case we need it again later. Paste it, and that at the original position, in case we need it again later. I can hide the sheet if necessary again, and now I simply place a cabinet and we want to move this cabinet in relation to the reference point by a value of, for example, 1000 millimeters. The width of the cabinet is 1500 millimeters. The depth of the cabinet is 550. After we have inserted the cabinet in the 2D plan top view, the Z value here is 0 millimeters. We see that clearly in the front view. Here we have a value of 0 millimeters. If that should not be 0, it is because another value is entered here, or we have assigned a value in the base area. We now take a look at the segments. We have a segment at the bottom of 200 millimeters, and this segment at the bottom is occupied with drawers. Here we have a design with a frame and a subdivision of 3 vertical segments, that is, 3 segments side by side. We can also look at the whole thing in the volume model. If we don't see any edges here, we can adjust that in the settings under Draw Edges. In the next segment, we have a height of 500 millimeters, and this segment is occupied with doors. Here we also have frame doors, and also 3 segments. Finally, we have another segment with a value of 500 as well, and here we can also have a subdivision of 3 segments at the front. Finally, in the upper segment, we have a design with shelves. Here we can enter 2 shelves. The number 0 is a grid. Here we can set, for example, that we want a 32 grid. Then we can see that the shelves are now slightly shifted because they have to fit into the grid, and in the case of the second shelf, for example, 300 millimeters. Here I can determine exact absolute values. If, however, only the number 2 is entered here, then an even distribution is achieved. we see that when we use measure distance in the screen plane alignment, we have exactly these same values. I don't see a display here for the snap point, then I really have to line up a point here, and we have 145 here. Now I can measure from here over to here. $145, and also from the top here over, and then we have 145 millimeters. In the right view, we can now take another look at the segments in the wireframe model. We have the segment at the bottom with a height of 200. Is half the distance between the shelves, and in the next segment, have again up to the middle 500, and then at the very top, we also have 500, and these segments are also shown here with a total value of 1200 millimeters. So I can switch back to the front view, and we now want to assign a base in the lower segment below. We want to have a mitered front here and at the back a flush finish with a height of 60 millimeters. At the very top, we want to have a lid variant with a rounded lid, for example. We enter an overhang on the left/right with a value of 20 millimeters. I now choose Edit/Undo, because this is, of course, the base area here, which is flush, and for the lid overhang here we make it 20 and 20 millimeters, and we see the result immediately.